Hi folks, this is Quabana with OpenMV, and today I'm going to be talking about our new and improved thermal sensor driver. So for the longest we've had the FIR module, which allows you to connect an external thermal sensor to the OpenMV Cam and get a thermal image along with a regular image at the same time. So anyway, we decided to finally upgrade this thermal imaging module to finally support our new draw image pipeline. This gives you the ability to now do things like smooth image drawing. So over on the right here, this is the output of the AMG 883. And so we have bicubic scaling that's being used on the output of the image sensor. And we've scaled up the output of the image sensor from 8 pixels to 160 by 160. And this gives us plenty of range for the bicubic scaling algorithm to do a magical job of making it look like the sensor is producing a high-res image. Just to be clear, this is what the actual output of the sensor looks like when it's not scaled. And so as you can see, there's really not a lot to look at there in terms of the 8x8 output of the AMG 8833. But once you turn on bicubic scaling, you get a much prettier looking image that can show, some kind of object in front of you and what that looks like. In this particular situation, it's a person, which is me. And you can even see that my hand kind of shows up in the picture. It's a little bit tricky, but you can see me moving my arm around in front of it. That's pretty sweet. And this sensor, the AMG 8833, is only about $40. You can also do bilinear scaling. It's not quite as pretty looking. As you can see, the bilinear scaling has these certain artifacts, so you do get the same kind of blobbiness effect. But you can see the bilinear scaling algorithm produces these sharp artifacts that look like crosses of where the pixel boundaries are. And this is just one of the issues of the bilinear algorithm. It is faster though, but if you want the best quality image, you're going to want to go for the bicubic, which is just a much better algorithm for high-res scaling. Cool. Now, besides for supporting the AMG 8833, we also support, as previously, the MLX 90621. This was the sensor that we sold on our thermal shield that we only sold briefly because it was way too expensive to stock and supply. And so we have the same sensor, and it doesn't have the same field of view. It's a 16 by 4 pixel sensor, so it's not quite what we're used to in giving us a picture, but it gives you kind of like a linear slice. And so you can see I'm moving my hand in front of the sensor, and you can see my head kind of here, and you can see my hand moving back and forth. Pretty sweet. And as you can see, we're actually getting about 200 FPS when we're pulling data from the sensor. So this is actually the FPS of us reading the sensor from the I2C bus at about 400 kilohertz, and then doing all of the operations to scale the image up and etc. And then finally, we have the 640, which is the highest resolution sensor that you can buy from Melinx's technology. And it actually gives you a pretty decent picture of what's going on. And so you can see my hand there, you can see my face, my body, and as I move around, you can kind of see what the sensor sees. So by default, the snapshot method, you have to supply it what it's doing right now by default is that it scales the image between a min and max temperature range based on whatever the thermal sensor sees. This produces a nice and easy way to get a good looking thermal image out of the camera with minimal effort, but you should actually try to apply a scale which will set the min and max temperature range. So you would supply whatever your min in Celsius and your max in Celsius then. And then that'll kind of clamp the temperature range between that. And so as you can see, the second I did that now, what the camera is looking for are temperatures between 20 and 40 degrees Celsius. And so I can kind of make that smaller, and we're going to get a different image output now. Cool. And besides for that, the system also supports a lot of different nice imaging features. So if you want to, H mirror the output, you can. So this is the same. Now let's go back to the other sensor, to MLX. So as you can see, the output is mirrored now than what it was previously. You can also V-flip it if you want. And we've even got transpose. And transpose is really useful if you want to rotate the image, because a transpose plus a vertical flip plus a horizontal mirror, different combinations of those three allow you to rotate the image by 90 degrees, 180 degrees, 270 degrees, and 360 degrees or 0. And then finally, you have all the same features as draw image in the new snapshot and draw IR methods. So you can add a color palette. If you want to do custom alpha palettes, you can also add that. Same drawing hints, and just a bunch of different general features along with alpha blending. Anyway, hopefully the new and improved FIR module will give you all the features you need for making cool thermal applications if you're OpenMV Cam now. Anyway, thank you for watching. Bye-bye. Can it see my thumbs up? Yes, it can. There you go. Thumbs up. All right. Thank you for watching.